Hello and welcome to Introduction to Physical Chemistry 1. This is the first in a sequence of 3 introductory courses that will launch or form the foundation for an entire curriculum in physical chemistry. That curriculum will include core courses in quantum mechanics, statistical mechanics, and all sorts of different topics, along with advanced courses in those areas, and specialized short courses in different topics, and then application. And so if you were to work through these 3 courses, you'll be prepared to head on to the rest of the curriculum. My name is Darren Olness, and I'm a chemistry professor at Concordia College. I've been teaching physical chemistry for 25 years. I've been teaching general chemistry for probably about 20 years, but I've switched over now to teach general physics, non-calc based physics in the physics department. So I'm teaching physical chemistry and physics as my main load. I also taught courses in advanced math for theoretical chemistry and in physical neuroscience. I live my life by this statement that is attributed to G.N. Lewis. And that is, physical chemistry is anything that's interesting. And I think you can read this 2 ways. You can read it in a more cynical way, that the only thing that's interesting is physical chemistry. That's a very narrow view. But I don't think that's the spirit, and it's certainly not the spirit I live by. And that is, physical chemistry opens up the opportunity to study anything that you find interesting. And that's the goal here, is to help you look at the world through the lens of physical chemistry. You found this, so this is the GNL project. The GNL stands for G.N. Lewis. This is supported by, you can find my webpage here, and the GNL project has its own sub-web page off of there. And because there's a little of an extension here, I'll just link to that in the description of this video. All right, the prerequisites to get started. Now note, this is not a physical chemistry course. So if you're looking for a course on physical chemistry, that actually I probably won't have a sort of standard physical chemistry course because I have the luxury of spreading this out over many, many courses. But this is not a standard physical chemistry course if that's what you're looking for. This is really an introductory course. And so in a sense, it's kind of combining general chemistry and general physics. So I think it's really important, especially if you're going to be self-studying, that you have a very strong, you feel pretty strong with algebra and trigonometry. If you've had calculus, great, but we won't be using calculus here. There will be some small areas where we will, I'll show some ideas from calculus, but I'll be careful to say, here's where we would use calculus. And if you haven't had calculus, just sort of watch us do that and then pop out the other side when we get the derived formulas. Then it would be helpful, although not strictly necessary, that you had a strong high school chemistry and high school physics course. It's good to know just things about the idea of matter and that there are chemical reactions and that there's energy that provides the impetus for molecules to collide. So just some of the basic things that you would get from high school. Supporting materials on the website, which will be linked to here. We'll find a page dedicated to this class, and my notes will be there. They'll be more or less following what we do here. There'll be a couple of things that I talk about here that aren't in the notes, and there'll be a couple of things in the notes that I don't talk about here. Along with the notes will be a large selection of homework questions. Many of them will have the answers there, but probably not the worked out full solutions. Then I really, really encourage you to pick up any general chemistry book and any general physics book. So you can go to a place like Abe Books or other places like that. Definitely don't buy a new one. Buy a used one. You could buy one from the 70s. It doesn't matter. They're all the same, and they pretty much follow the same order. So the basic core concepts have not changed in a long time, and that's what we're trying to nail here, our fundamental concepts. Now, there is a range of general chemistry books. So be careful that you don't buy something called a General Organic Biochem, or so-called GOB book. Make sure you buy just a regular college chemistry book. And then with physics, there's really two varieties here. There's college physics, it's usually called, which is non-calc based. And then it's usually called physics for scientists and engineers. Sometimes it's called university physics. So that will be calculus based. So if you've had some calculus, or maybe you're taking some calculus now, it'd be a good idea to pick up a calc based physics book. And otherwise, pick up a non-calc based physics book. Most of the things I talk about here will be found in that non-calc based book. So we will be missing some of the topics that appear in calculus based physics. One of the big notable ones is that we'll be doing a lot of our physics in 2 dimensions rather than 3 dimensions. So that'll be a little bit light on the 3-dimensional stuff in this course. All right, so I hope you're excited about getting started. I'm excited to get this out there. As I've been a professor, I've often sort of fantasized about how I would put together an entire curriculum on physical chemistry. It's given me so much. Physical chemistry has given me so much. I love to understand how things work and how nature works. It feels like you have a deeper connection to nature. So hopefully this is the first step in your journey. I'm not sure I can be able to respond to everybody, but certainly before this channel, if this channel numbers stay kind of low, then I probably will be able to. So feel free to reach out. If you are interested in a life of science, then I really encourage you to check out colleges and check out either chemistry or physics departments there. And it's a good chance to get a degree in a wonderful field. All right, so hope to see you the rest of the lectures.